Another part of bottom-up processing that I think is more plausible is prototype matching. Basically, we have a semblance of an idea of something that could be a prototype. So, for instance, what's a prototypical bird? Well, it would be more likely to name an oriole or a blackbird or a robin, smallish, and it flies. Are there birds that are not prototypical? Well, yes, an ostrich. An ostrich can weigh 600 pounds and it does not fly. And by the way, it's not necessary for the organism to fly to be a bird. It has to have something to do with hollow bones and feathers or something. So those are non-prototypical birds. Here are all the prototypes for the letter R, upper lower case. So the stored representation, instead of being a whole pattern that must be matched exactly or closely, a prototype is an idealized representation of some class of objects, like the letter R or a cup or a dog, etc. What's an atypical dog? A dachshund, maybe. Very long and low to the ground. Whereas a more prototypical dog would be maybe a lab, or just a slightly larger dog whose torso is further above the ground than a dachshund. So you could think of a prototype as an idealization of the thing it represents. And the prototypical dog, for instance, would be a depiction of a very, very typical dog, the doggiest dog you can imagine. Where do they come from? Well, Posner and Keel demonstrated that people can form prototypes quickly. And this is an array I'll show you here in a second. These researchers created a series of dot patterns by arranging 9 dots in a 30 by 30 grid to form a letter, a triangle, or a random pattern. The dots were then moved to slightly different positions in the grid. When the original patterns were designated prototypes, and the others, which were really variations on the same patterns, were designated distortions. And here they are. So here are the stimuli by Posner and Keel. Let's go way back to 68. So going back a ways. And so given that the participants had never seen the prototypes before, their accuracy in classifying them is surprising. So if you'll indulge me, I'm going to read the whole paragraph. Let's just take a second. Participants viewed the various distortions, but not the prototypes. And were not told that the distortions were in fact distortions. Participants learned to classify the distortions into groups on the original pattern from which the distortions were derived. After they could perform this classification without error, they were shown another series of dot patterns and asked to classify them in some way. The dot patterns shown in this part of the experiment were 3 types: the old ones they'd seen, new ones they had not, and prototypes also not seen. Participants correctly classified about 80% of the old ones, 60% of the new ones. And here's the important part. It's a lengthy paragraph. They were able to identify what a prototype was 85% of the time, even though they hadn't seen it. So that's an important distinction from that Posner and Keel research, is that people understood what the ideal representation was, even though it hadn't been seen. So I'll give you an example of a grant I was on from 02 to 04. The participants' job, and this was children, they were 6 to 10 maybe. So these kids are now in their late 20s. I'd be curious to know what they're up to. But on the left is something called a wug. And you can see it's a triangular character with legs and whiskers, and it's kind of silly looking. And I'd say to the 8-year-old, which one is the wug? And they'd say the left one. Now you'll notice the wug has changed. The arms have changed. The whiskers are longer. That might be it for now. But then I'd say, hey, which one's the wug? And they'd pick the left one. And again, it changed. The arms are stouter and the whiskers really short on the left. And on the right is another variant of the wug. Or, did I say geb? I'm sorry. I said wug, I meant geb. We had some mock characters there. Then we say, well, which one is the geb? Excuse me for saying wug. And the one on the right is the one that's the prototype. It was the average representation of a few that came before. So here's a mainstream geb, I should have said. Here's one that's a little extreme, but then the average of all of those that they may have seen before is the one on the right. And invariably, these 8-year-olds roughly chose the one that was sort of the average of all of the ones that came before, even though if they were really exaggerated like that one is, they formed a representation. So even if young children, we've seen exaggerated birds, extremely small birds like hummingbirds, and we've also seen emus and ostriches. But somehow when we think of a bird, we sort of think of the mathematical average, which might be an oriole or a robin, something like that. And we come to an average. And these kids showed that propensity in this grant project, testing these gebs going way back to exactly 20 years ago. It wrapped up in May of 2004. So the Posner and Keel study showed that we can even have prototypes of triangular patterns that they've never seen before, but nonetheless they'll correctly identify that prototype there. Now, this extends to faces. This is kind of fascinating research. Let's see, what did I do with it? This work extends to how we form and use prototypes in our everyday perception. The effects are not simply a function of artificial stimuli, such as a dot pattern. Cabeza et al. Showed similar prototype effect with faces altered by displacing features up or down by a certain number of pixels. And this figure shows examples of the stimuli. They reported findings similar to Posner and Keel, that research participants were more likely to recognize a prototypical face. And you can see the prototype faces in the middle. It's a little stretched here. Let me see if I can do a little justice. But the ones that are in the center, in the third row down, are just more mainstream and average looking, whereas the other ones, especially as your textbook depicts it, have stretched foreheads or shortened foreheads as a function of sort of a Photoshop. So the more prototypical, the more likely we are to recognize it, and we just have this tendency to engage in prototypical matching. So it's kind of a fun line of research, and it's amazing how people come away with an average impression. But you think about that, we do. Think of a car, you're going to think of an average car, not something extremely long like a 1970s era Cadillac, or something really short like a Yugo. Think of a bird, you'll think of an average one, or a dog, or anything. So it's amazing how we have an idealized version of something that you store over time that's more quickly recognized and more quickly dealt with.